Example 3, graph this function. Now, when you look at it, you should notice, hopefully, there's an x squared. X squared, it's going to be an even function. It's a positive 2, so I can see really quickly that this is going to be a positive, even function. And so, really, I pretty much know it's going to look like this before I even start. Okay, left side is up, right side is up. That's a positive, and that's an even. Okay, look at your shifting. X minus 2 tells me that we're shifting right 2, and then minus 4 over here means down 4. Same as what we've learned in previous sections. We would know that there's going to be a vertical asymptote because x cannot equal 2. Likewise, if you think about it, when you shift it down 4, y cannot equal negative 4. So we're going to have a couple of asymptotes. You're going to have a vertical asymptote at x equals 2. You got a horizontal asymptote at y equals negative 4. All right, now remember, we already pretty much know what this looks like. We're already thinking if that's an even function, it's positive, and even, it's going to look something like that. So really all we have to do is plug in some numbers to force that to happen. Let's just see. So if I'm going to make a table, the only thing I can't plug in is 2, because there's an asymptote there, right? So we know that we can't do 2, but we can plug in other things like 0 and 1. If I plug in 0, you have 2 over 0 minus 2 is negative 2 squared minus 4. That's going to end up being negative 3.5. Those of you with your graphing calculators, use your table feature, and the calculation goes easily. 0, negative 3.5 is down there. Plug in 1. 2 over 1 minus 2 is negative 1 squared minus 4. We do that calculation, we're going to get negative 2. 1 comma negative 2. Right there. Okay, so that pretty much fits with what we thought it was going to look like. Something like that. And then keep going. We know we cannot plug in 2, so maybe let's try 3. If you plug in 3, it's going to be 2 over 3 minus 2 is 1 squared minus 4. It's negative 2. So 3 comma negative 2. And then plug in 4. 2 over 4 minus 2 is 2 squared minus 4. Gives me negative 3.5. Notice the symmetry involved there. 4 comma negative 3.5 down there. Okay, there's my function. Now we have to find the domain and the range. So domain, remember domain, we're going to squish it on the x-axis. Everything's covered there except for 2, so negative infinity to 2, unioned with 2 to positive infinity. Now the range is a little bit tricky. You want to think it's all real numbers, but it's not all real numbers. If you squash that onto the y-axis, you're only talking about up here. Okay? The range is only going from negative 4 to positive infinity. If you read this from left to right, this part is increasing and this part is decreasing. So you've got both increasing and decreasing on this side. The yellow part, the yellow highlighted, is increasing. So from negative infinity to 2 is increasing, but the blue highlighted is decreasing from 2 to positive infinity. Determining asymptotes. This slide is going to be really important for you. You're going to need to have this out when you do your homework questions, because a very big part of doing these problems is going to be finding the asymptotes. Okay? So there will be a vertical asymptote when the bottom of your rational expression equals 0. there will be a hole when the bottom equals 0 and it cancels. You're going to have to do a little bit of factoring and maybe a little canceling to figure out where there's vertical asymptotes and holes. Horizontal asymptote, a little bit harder to deal with here. You have to look at the degree of the top and compare it to the degree of the bottom. So you got some conditions there. If the degree of the top equals the degree of the bottom, y equals the leading coefficient of the top divided by the leading coefficient of the bottom. And so what I mean is like this. If you have a function that looks like, let's say you have 4x squared plus 8x minus 9 over 7x squared minus 2x plus 1. Okay? The leading coefficient, the degree of the top is 2, the degree of the bottom is also 2. So the degree of the top equals the degree of the bottom. You're going to have a horizontal asymptote at y equals 4 over 7. Those are your leading coefficients. The 4 in the front, the 7 in the front. Okay, so lead coefficient of the top over lead coefficient of the bottom. If the degree of the top is less than the degree of the bottom, you have a horizontal asymptote at y equals 0. So that one's a little bit easier to come by. Oblique asymptote. Oblique means diagonal. It's probably the hardest one to do. If the degree of the top equals the degree of the bottom plus 1, you're going to have an oblique asymptote, and that is going to be y equals, this is going to be tough, because you're going to have to do long division. Long or synthetic, I guess. So whatever you get when you do a long division problem or a synthetic division problem, ignoring the remainder, that's what your oblique asymptote is going to be. It's going to look something like, probably like y equals x plus 2 might be an oblique asymptote, a diagonal line, as opposed to vertical or horizontal. Note, a graph cannot intersect a vertical asymptote, but it may intersect a non-vertical. So it might actually cross a horizontal or an oblique, but it will not cross a vertical asymptote.